Okay, you may have been wondering why we did that stuff on exponential growth and decay just before this, when actually we'd done all the work with e's and logs ages ago. All right. Well, the reason is because differential equations very often turn into exponential growth or decay, and here's a classic case where they do. So be prepared for an exponential growth or decay to turn up as a result of a differential equation, especially one of this form. So dy by dt is ky, and all I'm doing now is separating the variables, and it tells me what the answer is going to look like. Okay. So don't worry about this y naught just yet. We'll just take the differential equation. So dy by dt equals ky. Oh, they've decided to use t's instead of x's. That's quite common because often there's a relationship where something's changing over time. So time's quite common, t's quite common instead of x, but it doesn't change things. We're going to multiply by the dt. So we're just going to have a dy on this side equals multiply the other side by dt ky dt. But I haven't separated the variables yet because this y is in the wrong place. Now don't be a twit and divide by the k while you divide by the y. A k is just a constant, but we don't want it on the bottom of a fraction. It's perfectly happy where it is. Okay, so try and leave your constants on the top of the fractions. This is so much harder if you divide by the k at the same time as the y. Okay, so we have got the integral of, well, I'm not integrating it, I'm dividing by the y. So 1 over y times dy equals equals k times dt, but these are both going to turn into integrals. Okay, remembering that k is just a constant. Okay, so 1 over y, okay, top's the derivative of the bottom, so that's just log of the bottom, log of y. Okay, don't put on the modular signs because we don't put those on until we need them. And integrating k is not a half k squared because that is a constant, it's not a t. Okay, if you integrate 3 with respect to x, you get 3x. If you integrate k with respect to x, you get kx. But I'm integrating k with respect to t, so I get kt. And I mustn't forget my constant of integration, but I only need it on the right-hand side. Now I can make the ln go away, so y equals e to the power of kt plus c, but I know that the plus c additive constant becomes an a e to the power of kt. I'm not even going to prove that, and that's, you know, if you're confident doing that, that's fine. If you want to go back to the earlier videos, you can see the detailed explanation of why that works. Okay, so all right, now I've got to get the required thing. So I'm supposed to be getting y equals y naught e to the kt. So where does this y naught come from? Well, they're telling me that y equals y naught when t equals 0. So I've got a value of y naught. Okay, it's an algebraic value, it's a letter, but it's still something to plug in. So if I plug in y equals y naught and t equals 0 into this, I get y is y naught equals a e to the k, whatever that is, times 0. And of course I don't know what k is, but I know that k times 0 is 0, and I know that e to the power of 0 is 1. So a times 1, which is a, equals y naught. So if I plug that back into my equation, then y equals, okay, it was e to the kt, but now I'm changing a to y naught, so it's y naught e to the kt as required. Marvellous. Oh, you couldn't see any of that. Yuck. All right, okay, so what I did there is I took this a equals y naught that I had worked out, and I plugged it back instead of that a. So this is y equals this thing, and I've changed that a to what I now know it is, which is y naught. And I got exactly the equation that they told me I had to get. And then for dotty 2, we've just got to find t in terms of k when y is increased to 5/3 y naught, which sounds horrible, but the fact they've got a y naught in it helps. Y equals 5/3 y naught. Okay, implies that, well, I plug it into the equation. So y has got to become 5/3 of y naught. And that's got to equal y naught e to the kt. All right, and look what happens. The y naughts cancel, so that's quite common. So e to the kt equals 5/3. So I'm not going to write that out separately because I'm running out of room. I'm going to make the e go away. So this is now just e to the kt. I'm going to ln it to get kt. So I have to ln the other side. The y naught's been cancelled, so this is just ln of 5/3. Okay, and I have to find t. What's it? T in terms of k. So I just have to divide by the k. So t, I'll put an implies sign, t equals divide by the k, 1 over k, ln of 5/3. And, whoops, that is my final answer. That was fun.